Hi, Julie.
Hi.
I don't know how many people are going to come to this. I've
Right,
gotten
yeah.
many cancellations. So, Julie, on these meeting things, these blog things on the invitation are all wrong. It says June 21st, May 6th
On the webpage?
on the blog itself, on the invitation notification. You're going to have to update that. Do you get it yourself? Sometimes you don't get it if you create it. Hello.
Yeah.
Do you get the invitation?
Yeah.
See all that stuff? You need to remove that. So I don't know how many people are going to come today. I got a lot of cancellations from people. So Lee, are you doing research this summer? Or are you done with research?
I'll never be done with research.
There you go. It's in your blog.
Yep. Yeah, I have like 30 papers lined up to be published over the next 2 or 3 years, so a lot to do.
I'm in the same boat as you. I got a lot to do. But are you working with somebody? I know you have a MidPick grant, right?
Yeah, well, Kiangsu's the lead on that, but I'm a collaborator on it, and we're also going to be looking at our permanent plots that are 40 years old in the Porcupine Mountains in Sylvania that kind of have partial earthworm invasion fronts just starting there.
Do you know what species?
The typical European suite of species. So yeah, night crawler and a few Abractidea species and Lumbricus rubellus.
So welcome you all. I see that Julie, the host, is here, and Lee Freilich is here. He was just talking about his research this summer, going to the Porcupine Mountains, and he has 40-year-old long-term ecological research plots. They're just being invaded by European earthworms. And I hope he's going to tell us more about that. And Laura's here from the DNR, and Erin here is from the Arboretum. Welcome, all of you. And Simran is there from my lab, and Grima is there from my lab. So I got a lot of and Jim is somewhere. Jim Connolly is somewhere.
Yep.
Is there anybody else I missed? No, that's it. So I got a lot of cancellations from people this time. So I think this will be our last meeting till September because everybody goes off and does their field work very soon. So that would be good to have you all in September. We'll send some emails and ask you to, give us summaries of what you were doing for the summer. So I would like to start. Oh, here, Shannon's here from Maine. Hi, Shannon.
Hey there.
From Vermont. Sorry, Vermont. Maine was on my brain because Gary Fish of Maine, I think he contacted some of you. They're going to have a Maine State online jumping worm symposium. And it's sometime in June 15th and June 14th. So I think some of you got an invite to talk. It's not a very big symposium. We're still going to go along with our symposium, which we hope to be bigger and have more research-based information at it and more information about regulatory issues. So you'll hear more about that very soon. So that's my introduction. So who would like to first give a summary of what they've been doing? Laura, how about you? Can you summarize? Are we having any changes in regulatory issues or?
No, it's been pretty quiet. I still randomly get jumping worm reports from people every now and then, even the winter, where they've sent in pictures that they took last fall and someone must have directed them to send a picture in. But no regulatory changes or updates.
So last time we talked about these maps, like the invasive species site that has maps. And then there's Erin was walked me through some of them. We had a Zoom meeting, independent of this Zoom meeting.
Are there more maps than EdMaps?
Yes, there is another
Okay.
iNatural. Let Erin talk. Erin, you into it.
Yeah, somebody did start them in iNaturalist as well, but I don't know how much they would differ from it. And Vera, I'm blanking on how in depth we went when we
We
met
do
with Karima.
import records. We
Okay.
do import records from iNaturalist into EdMaps.
Okay.
They have to be research grade. So I
Yeah.
know there are, worm reports in EdMaps. One wonky thing is a lot of worm reports in iNaturalist are to the species level, and we haven't been wanting to commit to species level over photographs. So we've been putting things in to EdMaps as Amenthus species. So I don't know how confident we are in the species level identifications in iNaturalist.
So there is a paper that I will send you, Laura, where they have a distribution and it's a research paper. So I don't know how you take research papers and put them into the.
Yeah. I've told people when they've gone to these, national things on jumping worms, like people got to share their data, because it's really hard if you've got to like pull a map from 3 different, PDFs of different research papers that have put things in there. So that's kind of the beauty of things like iNaturalist and EdMaps, is to try to get all these, various things into one spot. But yeah, I can't take a research paper and put their data into EdMaps, because I don't, have any of their original sources.
So it would be the responsibility of the authors of the research
Yeah.
paper. And who would they
Yeah.
contact to do that? Could they contact you and you would help them do that?
Sure.
Yeah, because there's a research paper, there's just one, and I'm sure there's others, and they went and sampled themselves, and there's many more sites than is in the invasive
Yeah.
species website.
Yeah, no, EdMaps only has things from states like Minnesota and Wisconsin that actively use it, right? The whole, East Coast looks pretty blank, even though we know there are jumping worms there.
Okay, well, I'll send you the paper, and I think most all research papers now have contact information on the bottom, how you can, at least an email to contact that person.
Yeah.
So that's a good aside, that any of you who bump into research papers, Julie has been looking, and we just sent you in this invites the summary of research papers she's found over the last year. But if you come across a favorite and find a good research paper, please send it to us, because we want to put it on the website for research-based information for people to see what's out there. So please help us with that. So we went on a journey. This is how, Erin, maybe this will remind you of what we were doing. We were trying to figure out the species of our jumping worm in our culture that was collected by Coffee Hall at the university. And so the jumping worms are supposed to have this ring of 30 ceti around a segment. So we couldn't see it. So we went off to the museum, and we contacted somebody who's been in the museum like 60 years. And he got a microscope out and helped us see it. And then at iNaturalist, they had a beautiful electron microscope of all the ceti on the species we deal with. And so that's was, Erin, maybe this is reminding you our journey. So we copied those. Obviously, there you can borrow them from iNaturalist. Ask for rights, and so it would be nice to find other research papers that have done electron microscopy, so that you can identify some of these other species very accurately. So it was really easy to see the ceti that were common on, the Amanthus species that we're dealing with. So we're kind of interested in that. If anybody comes up with a research paper that's either qPCR or morphological identification, we're really interested in creating a nice key to help everybody identify their species. So we're kind of depauperate on information right now about that, but there is some information out there. So I see Jim Calkins joined us. It's pretty clear. Your phone is really good, Jim. You look just like Jim.
I'm sitting in Eau Claire with my mother here.
Yeah, I'm
She's having a shake here.
oh, that's better. That's a good afternoon. The sun and a shake. Looks like it's sunny there in Wisconsin. It's not
It,
here.
it's partly cloudy. Yeah, it's coming up.
Here it's partly cloudy too. So, Jim, do you have some regulatory information to share with us?
Not really, I guess, other than the fact that I have made some contacts at EPA and through MDA, and they're going to set up a meeting. So when I hear back from them, Vera, if you want to attend, I can loop you into that as well.
Okay. So we should talk soon.
Yeah.
All right. So not much on the regulatory front. That's new. Anybody have any questions for Jim? So I don't even know. I kind of want to ask this, but I'm afraid to ask it, but I'll ask it anyway. So those nurseries that have found jumping worms, are they in any way having problems with selling their stock, or is it all working out so far?
I think there's only one that I'm aware of that has gone public with the fact that they've had jumping worms on their site. And they're in St. Paul, and they have not had any problems, surprisingly.
Okay, very good. So that's a good news.
And there's two. There's another one down in Rochester, and they have not had any issues either.
Very good. Okay. All right. Well, thanks, Jim, for that update. How about you, Aaron? You have any update? What's going on at the Arboretum?
Brandon Miller's GRA gave a research update for Arboretum staff just on work that she has done at the Arboretum. So she just did a very limited container, nursery container mortality type thing for jumping worms with different pesticides and non-EPA registered things. She's been very, very clear with everyone. Nothing is labeled for jumping worms. These are closed nursery containers on a gravel site. This was the Brandon Miller MDA specialty crop block grant that he got. And so different things were tried, but basically the two largest or the two most successful chemicals that she found, nothing gave 100% mortality. But the good news was that nothing yielded phytotoxic effects on any of the plants. So any of the drenches that she did were safe for plants. But she did find that the fungicide thiophanate methyl had the highest rate of mortality, which was over 85%. And then the new formulation of 7, not the carbaryl, but whatever the other one is, the synthetic pyrethroid, that still gave over 80%. So she said that what they were hoping for is maybe next steps trying to dial it in and see, what rate is still safe enough for plants, but could potentially yield 100% mortality. She also was very clear saying, this is for containers only. This is not for field work, for landscapes, because of the effects on microbiomes and other off-target organisms. But yeah, that was kind of where she was at right there.
Great. I'm glad that things are working out for her. And she's doing a master's, so she's going to repeat that this summer?
Yes, correct. And then she's also going to do a temperature kind of sort of mulch heat treatment to see what kind of heat treatments would most successfully prevent jumping worms from infesting bagged mulch, bagged substrates, really, because we have received reports that yes, jumping worms can, if there's a breach in any bagged mulch, or if it was bagged while there were still jumping worms in the mulch, they can survive in that. And that's another way that through the industry, we could be spreading jumping worms from one place to another. So she's trying to show either different, she's going to be putting eye buttons in pallets of these bag substrates to measure the temperatures based on different sites, how many hours a day those bag substrates get of direct sunlight. and then trying to determine if we can hit that. What Brad and Marie over at UW-Madison had found was 104 degrees for mortality for jumping worms, to see if she could still get that with either wrapping the pallets in black plastic or if clear plastic is still going to be enough, depending on the type of mulch.
So that sounds really good. Good idea there. So what fungicide did she use?
Thiophanate methyl. It's a pretty common fungicide, although turf experts don't really like it anymore because they are finding that a lot more turf diseases are resistant, and it's not as effective as it used to be. It's still pretty widely used. It is off patent, so it's sold under many different brand trade names, but it's very inexpensive. It's I think according to your site, Vera, and definitely according to UCIPM, it's bee friendly, or at least there's no bee precaution pesticide rating for it. Even though it's still considered by some people to be kind of nasty, it still only carries a caution signal word. But yeah, golf courses apparently have used it for a very long time for their turf diseases with the off-target impact of killing worms on their greens. So it was actually Tessman, one of our sales reps at Tessman in St. Paul, who told me, yeah, you should try thiophanate methyl to kill jumping worms because we know that it kills the European ones on golf courses. And so we kind of put that into Brandon's proposal, and it does seem from Jenna's data, it actually did, no offense, Jim Connolly, but it did give a higher mortality rate than the rate that she used for tea seed meal. But using tea seed meal pellets, like the castaway pellets, I think it didn't quite distribute evenly throughout that nursery container because she just did a top broadcast of it, and she didn't put in a lot. So again, it's dialing in those rates. But at the label rate for drenches for T-bird, the thiophanate methyl fungicide, she still got pretty good mortality.
So when she used the castaways, did she use the Anderson formulation or the Planet Turfs formulation?
I think the Planet Turf. It was the same stuff that we used for Lee's mid-pick grant. And that was 301. So I'm pretty sure we got it from Planet Turf.
So thiamol is the most common name of thiophanate methyl, thiamol. But I know it is part of when you buy some of these fungicides, they're mixtures, and I've seen it as a mixture. So all fungicides have a 4, non-toxic to bee, but nobody has looked at everyone who does these bioassays does these short-term LC50 bioassays. They don't do the, long-term effects, chronic, even 2-week chronic. And so there are papers coming out of Wisconsin about the microbiome of bees, bumblebees, and other data from other universities about honeybees and how these fungicides just completely, strip out all the important fungi, microflora in the guts of bees. And it does have an effect on brood and have an effect on adult survivorship. But that is never going to catch up with the fungicides because all the EPA registrations are short-term, 4-day LC50 studies. So to get them registered, and so there's never going to be a long-term study. That's not part of what EPA does to register things.
Yeah, UCIPM will rate fungicides like propiconazole and meclobutanol as don't apply when bees are in the vicinity. But then things like mancozeb and thiophanate methyl, those carry no precaution, according to their rating system. So it's interesting to see the different types of fungicides and what they consider potentially hazardous.
So Kate is here. Hi, Kate.
Hello, sorry for my tardiness.
No, that's all right. So we've gone through a couple people, and we have a video, so we posted on the website, and there's a link to the videos on the website. There's a page with the blogs and the videos, so you can catch up if you want, Kate, with what we've done up to now. So Erin, do you have any more to add?
Nope, just like I said, you and I had talked about Brad Herrick's undergrad assistant that she wanted to come back to the Arboretum this summer, but we'll chat more about that later. She'll be
Yeah,
back in
no, that's
Minnesota in
fine.
mid-June. Yep,
We're gonna do that, so that's fine. We can talk
sounds
later.
good.
Yeah.
Okay.
Perfect. All right. So Shannon, do you have something to talk? How's your website going? How are things going?
Yeah, hang on, let me sit down. I'm multitasking. 'Cause I think some
Can
of
you
the-
show us some things? If I make a share, a multi-share, can you show us the website?
So not yet. So where we are in terms of that right now is, so we actually have the beta version ready to go, but we're going to send back a first round of edits, and then we're going to get the team together. So the Healthy Soil Collaborative Group, which Erin and Vera, that includes you guys. And we'll go through, there's some things that I want the team to sort of look at before we share it with the wider world. And then the only other major thing that we're waiting for is to secure a fiscal sponsor to make sure that we can get those donations. So we were chasing one thing down, it sort of fell apart. So now we're exploring some other leads, which are actually very exciting, but I don't want to speak about them because it's premature, but we're making some presentations and we're having some great conversations. So we anticipate this is probably a couple months away. I know we've said that for a while, but things are looking really good. So pretty soon we will be reaching out to the team to get folks together to go over that, and then it should be ready to go. And then we'll be able to share it. Like once we've had a chance to do that, then I would absolutely love to share it on the blog as well.
So just if you haven't met Kate before, sorry, if you haven't met Shannon before, Kate, because I think you're one of our newcomers. Shannon works with the people at the University of Vermont, the Jumping Worm Working Group up there, and they're developing a rather large website with that's information based, but it's also very user friendly. It has some it's dramatic. It goes through some music and to talk over and explaining how worm invasions can cause ecological risk in forests. And so she doesn't want to share it with us right now because it's not done. We've seen it in an earlier blog, but it looks really good, and they're going to use it to try to advertise to get some research funds to help support jumping worm research in the eastern states and maybe in the Midwestern states as well. So
Definitely in the Midwestern states. We're really hoping that this can be a body that, I mean, we're called the Healthy Soil Collaborative because we want to collaborate with other scientists. We want to collaborate with community members and stakeholders. Like I think some of the folks have already in this field have already gathered some really great data just by reaching out to the public because we know gardeners and garden centers are on the front lines of this. So being able to do that and then having more of a unified body to really try fundraising to support this research because it's hard for everybody. So that's kind of the goal. And across, New England and the upper Midwest and Southern Canada, our team members spread around, and I expect we'll be growing in time, but we're just getting off the ground. So yeah, beta version. I just went through it. We've got to fix some fonts. We've got to change a few things. And when we get the group together, we'll all have to settle on titles because rather than chase everyone down, I've just given everybody the same title and we'll all have to figure that out. But I'm pretty stoked about this. So I'm really excited to show you guys.
So somewhere back in the conversations, Erin had gone to a jumping worm working group meeting about 2 years ago. And do you know if that working group is going to have another meeting soon, or do you guys? I know you were involved with them. The Cornell people, I think. Is that right, Erin? Is it the Cornell group?
No, this was from my recollection. I thought that it was held in Vermont, so I thought that Joseph had coordinated it. I know Brandon Miller did attend. It was just a weekend trip out there. Brandon was there. Anise Dobson from Yale was there. And I believe Joseph and Miriam were both there. I don't remember who else, but yeah, Shannon, do you remember? It was April of 2023.
It sounds like the second meeting of the Healthy Soil Collaborative because those
Okay,
are
yeah,
a lot of the folks that are in there. And so
yeah.
we were getting together because we needed to finalize a lot of the big ideas that would feed this website, like our study agenda and, the questions that we need to be focusing on. So to help orient that. So I think that was that meeting, in which case we definitely will be meeting again.
So do you ever interact with this Cornell group, or do you ever talk to anybody? And they have a Cornell working group on jumping worms. You can find it by just Googling it. Do you ever interact with them? No, they haven't come. I thought they were at that meeting, but obviously they weren't. All right, if anyone
I
has any
sent,
information, yeah, go for
oh,
it.
sorry. I sent Julie all the contacts that I could remember from the Healthy Soils meeting, but then
Right, we
also
got that, yeah. Yeah.
Tim McKay from Colgate. So I don't know if Julie, do you remember if there were any Cornell email addresses in there? Okay.
Well, Cornell is the website that has it, that you go to find the working group information. I think the guy from Colgate is a major player in it, along with some researchers at Cornell. But it's called the Jumping Worm Working Group New York, and I'm clicking on it here. And they have a website, Shannon, if you want to check their website,
Yeah,
Invasive Jumping Worm Observation and Discussion Group.
sounds like we have
And
members in common.
yeah, so it might be nice to, says they have 7,100 members, so it might be nice to try to figure out how to contact those people. All right, thanks, Shannon.
Thank you.
Do we have any more updates from people? How about Jim Connolly? I know you've been off in Portugal for a while. Have you bumped into anything new? You still there, Jim?
I gotta unmute.
Oh, okay.
I'm trying to unmute. I'm trying to video. Okay. Go Cougs. Sorry. There's nobody there from Washington State University. From a commercial interest, I heard the information on the thiophanate methyl and the carbaryl. And yeah,
But
it
it's
would
not
be,
Carbro, Jim, it's not Carbro. So the new 7
yeah,
is actually cyfluthrin, I think. I'll look it up. So it's kind of
cyfluthrin.
weird. They're using 7 now as a trade name for like a company name, and then
And so it's
and-
lambda cyfluthrin,
yeah, there you go. It's lambda cyfluthrin. There you go.
which has a nasty label when I ship that
It has a
around.
higher warning label.
I
Sometimes
think,
it's a danger
yeah,
label, lambda cyfluthrin. Warrior is the name for agriculture.
okay, all
Yeah.
right. Yeah, it's got a different UN number, which is the number I have to be aware of when I'm sending stuff in the, on a truck or something. But in any event, Planet Turf has gone through quite a bit of work to register the TC meal as a soil amendment in 28 states. And each one of those states asked you to give a purpose statement. So we've focused on the 80% organic matter that the product's made out of, and the percent of carbon that's in the product, which I think is, can't remember the number now, 40% or something. And then the 15% saponin, which I found enough research data on the use of saponin containing plants to improve, to benefit soils. It's rate dependent. So most of the states have accepted those 3 ingredients as beneficial soil amendments. And we're all aware that landscape and turf grass managers have issues with invasive worms, and maybe they'll use thiophanate methyl. Maybe in the past they've used carbaryl. I would hate to see them, if somebody said, hey, send me a gallon of lambda cyfluthrin for my worms, I would hesitate. First of all, the worms aren't on the label, so they'd be going after some other insect, like a grub or an armyworm, which we don't have, by the way, in the Pacific Northwest. So I think, and also promoting the fact that we've obtained, not that it means a whole lot, the OMRI certification for the product. I don't know what anybody, I'm not real familiar with it other than you see it on stuff. And I guess you think it's organic. But as far as the distribution of the product, I don't know what this year is going to be like in the way of calls for the product as a soil amendment, but at least we're not selling a bag of nothing, which was kind of weird. Just like a bag of straw. Oh, this is a bag of tea seed meal. But I think the word in all the blogs and the garden shares and the nurseries that are talking to each other, it's been pretty effective in helping them avoid these outbreaks. So that's from my end of the story. And I don't really have anything else to, can anybody hear me? Oh, okay.
Oh, yeah, we can hear you.
But I appreciate the information you're providing. And if you ever get invasive worms as a universal pest in the United States, that would be great for you, for everybody.
I think everybody's working on it in their own way.
Yeah.
So when I look up the 7 label, Erin, maybe you can look it up too. I see it's zeta-cypermethrin, not lambda-cyhalothrin.
SETA?
Zeta-cypermethrin, which is another pyrethroid.
I'd
So
have to look. Is that labeled for landscapes and turf? I don't know.
yes, it is. It's labeled for
It is.
7 insect killer, which is no longer carbaryl, is a pyrethroid. Zeta-cypermethrin
Okay.
is labeled for landscapes, for both flower beds and lawns. I don't know about a pot label for it. I've never seen a pot label, so you'd have to use a different formulation. So I don't know that.
Okay.
So
I'm wondering we know that you have to put at least a half an inch of water on the granules to get them to dissolve, release the saponin, and move down through the soil, come in contact with the worm. Then the worm almost always comes to the surface. And if they don't come to the surface in 5 minutes, they might recover underground. I don't know. But generally,
yeah, that's certainly something we will check out in our research, because
yeah.
getting them to the surface to die is really important, because a lot of these insecticides don't penetrate very deeply.
Mm-hmm.
Even though they're systemic, that means systemic in the plant. Now, if it
Yeah.
gets in the roots and then these jumping worms feed on the roots, well, then it might be really helpful to use a systemic something, like a systemic fungicide. But we don't know that yet, whether they feed
Yeah.
on root hairs or they're just feeding on organic matter. So that
So
all has to be looked at. Yeah.
Yeah, if they didn't put a half an inch of water on and at least 10 pounds of product per 1,000 square feet, and it works differently in sandy soils or high organic soils.
So they were doing it in pots, so I don't know how many grams they added per pot. So you
Yeah.
obviously don't have a pot rate, so you have to translate from 1,000 square foot to the diameter of a pot. And so
Yeah.
I don't know what number they came up with, how many grams of, the tea seed meal to put in a 10 or 6-inch pot. I don't know that.
Yeah.
Erin, do you know that?
I can't remember offhand. I'd have to go and see if I can find Jenna's data on it. But yeah, I don't think we did 10 pounds per 1,000 square feet, Jim. I'm pretty sure if we did any, it probably would have been half of that. But even so, it felt these were just 1 gallon nursery containers, so we wouldn't have used a ton of product anyway. So I do think that, yes, the main reason we still saw some mortality, we just didn't see nearly as much as we would have expected to.
Yeah.
Because we have used tea seed meal before, and it is great. It works very, very well. There was another older product too of tea seed meal that was called Rhizoaid, and I think that was made by Brandt. That's one of the discontinued
Correct.
ones. That was
Yep.
incredibly water soluble. So in that case, what I would do is I would actually mix it into a gallon of water and then just irrigate,
Yeah.
plots like that. Worked perfectly, even at half label rate,
Mm.
or what I would consider half label rate. So I feel like the water solubility, like you're saying, Jim, you need a lot of water to break down those granules. But once you do, I feel like it is very, very effective. But yeah, I'm thinking that Jenna just didn't have the proper rate for tea seed meal. We were excited when Lee was doing his Mitbake project. We were excited for tea seed meal because we wanted to choose the least, toxic methods that we possibly could for forests. There's no way we would ever use thiophanate methyl or carbaryl or anything like that in the forest. So yeah, we were still expecting it to work pretty well in the nursery pots, but I think that our rate was just wrong.
Okay, fair
But I
enough.
mean, that's why we're talking about this, because those of you who, listen to us do science, science is only as good as your experimental design. And you start doing it one way, and you just may miss something really important to make it work. So maybe the thing is that you soak this tea seed meal before you use it. I mean, that's why somebody gets one set of data and then you figure out, is there a way culturally to manipulate it? Because I agree with Jim, it's much better to promote a biorational than to promote something like, a pyrethroid. The pyrethroids are kind of a weird group. When they registered them at the EPA, they were hoping they had different toxicities, but it ends up like they're all very similar in their toxicity and their mode of action to insects. So some of them do have like I said, warrior lambda-cyhalothrin, that has a danger label because they use it a higher amount of active ingredient. So, but anyway, it would be nice to come up with some management that works very efficiently, but that is a biorational that it doesn't, people can use it and sell the plant and not have to worry about residues in the pot. So I think that's really good for all of us to realize science is iterative. Somebody starts with something and then you add on to it and try to figure out a different way to work with it to make it more effective. So, everybody has a contribution here until we figure out a good answer. So thanks, Jim, for the update.
You're welcome.
How long have you been going to Portugal for the winter?
It was great. I've been there a number of times. I consulted on some golf courses over there like 20 years ago, but it's a wonderful country, and the produce and the food is amazing, and it's quite a shock when you go grocery shopping in the United States. So we enjoy it very much.
Well, sounds good. Sounds like something Lee should do when he retires.
Yeah, for sure.
So thanks, Jim. Thank you very much.
You're welcome.
Lee, can you go on and continue what you're telling us about your research on earthworms, what you're going to be doing? Are you having trouble finding the unmute? I see you looking confused along the bottom. So you have to click on the black banner and then it comes up. You can't find it all the time. So it's over in the corner. I don't know how to help you with this, Lee.
Oh, is it me you're talking to?
Yeah,
Oh, I thought you said somebody else. Sorry.
no, sorry. I thought you couldn't. Sometimes
No,
the
no.
the microphone, the unmute disappears. On the new version,
No.
sometimes on the bottom left, it disappears with the banner. So you were
Yeah.
saying you're going to continue your work. You're looking at invasive earthworms in these 40-year-old long-term ecological research plots.
Yeah. Yeah. And one of the earthworm invasion fronts hasn't moved in 40 years, which I just find to be amazing. Like it hasn't even moved a foot. It's a sugar maple forest, and I have no idea what might be going on there, whether there's some nasty soil fauna there that kills the worms, some sort of nematode or something, but there are weird things going on out on the landscape.
So by
So,
weird, it's unexpected. You'd expect more earthworms.
yeah, I would have expected over 40 years that that invasion front would have blown through the whole mapped plot, but it didn't move a foot. Otherwise, let's see, our paper about the changes in soil temperature and structure caused by jumping worms from the Arboretum is getting closer to being published, so Kyung-Soo and Tyler Bauman are working on that. And that was from my first MITPIC grant. And we're going on a field trip down to the Rochester area, well, two of them actually, in April and May, to see sites of jumping worm invasion there. So I'm also teaching a class at the Lifelong Learning Institute at Rochester Community College about earthworm invasion. And then we're going to go out in the field and look. And so we're hoping to find more invasion sites so that we can have more than just the ones at the Arboretum and the one at Lake Rebecca, because they might behave differently in a different landscape. So, Nate Lund has installed many erosion pins to study the effect of erosion caused by jumping worms. And so we should start getting results from that this summer, because those were installed last fall. And then, of course, the native plant strips, we hope will grow this summer, and we'll be able to see whether they are able to contain the erosion.
This is what's going on at the Arboretum, the plant
Yeah,
strips?
Arboretum and Lake Rebecca, and hopefully we'll find some other sites in Rochester. Also, let's see, I was out to Western Massachusetts. Jumping worms are pretty widespread there in the Berkshire area. In Western Massachusetts, I noticed that a lot of the forests had a pretty high density of jumping worms and granules. Not surprising, because summers are cooler there than they are here, and I think cool summers really favor jumping worms. On the other hand, I talked to somebody who lives in Kansas City, Missouri, who has a jumping worm invasion, and I was surprised that they could even survive the summer there. But I told them to start looking and see if this is just east and north facing hills, is it the north side of houses? And, to start looking at the soil temperature issue, because I wouldn't expect them to be able to live in western Missouri or Kansas, given that the adults are killed by warm temperatures so easily. Let's see, I have not found any jumping worms in upper Michigan or northern Minnesota yet. And I keep looking every time I'm there. So on the other hand, they've now been found on the Door Peninsula in Wisconsin. So maybe the coast of the Great Lakes will be more susceptible because they also have cooler summers. So yeah, when you get within the lake effect zone around the Great Lakes, the summers are probably as cool as they are in the very northern part of Vermont, even though they're in the Midwest. And that's really key for them, is to be able to lay eggs at midsummer and have the soils be warm, but not too warm for jumping worms. Let's see.
So isn't this kind of weird that they're supposedly tropical insects, and you expect if they come from Asia, are they? I know there's altitudinal gradients, so it might be cooler if jumping worms are in the top of a mountain or something in Asia, but seems it's kind of warmer in Asia. So
well, these
explain
are
that one to
from
me.
these species that we have are from like the main island and northern island of Japan and adjacent Korea, and it's actually into the cool temperate zone there.
Okay.
Well, it's warm temperate in the very southern part of Japan, but northern Japan is cool temperate, and Korea, South Korea is also cool temperate. So so they're not in places that are that hot, except for Amynthus gracilis, which,
And that's the one we think is in lawns.
yeah, because I know for sure from this student at Akron University that Amynthus gracilis is found in open lawns in Ohio. So they must be the most tolerant of warm summer temperatures of any of the species.
And is that species also from Japan?
Oh boy, I don't remember right now. So, yeah, I would expect it to have a little bit more southerly distribution than Amynthus agrestis because it's so heat tolerant. And I know Sam James has told me about Amynthus species that live in fully tropical environments and they can withstand soil temperatures that are incredibly hot. So I know there's a gradient in Amynthus species from the cold temperate to the tropical, just like a series of overlapping species that have different temperature niches. Yeah, I was in the Adirondacks. I didn't find any jumping worms there. It's a big place. You can't go everywhere in the Adirondacks. I saw lots and lots of European earthworm invasion fronts in the Adirondacks, basically starting at every parking lot for a hiking trail. Just about everywhere in the Adirondacks, it was stage 5 of European earthworm invasion around the parking lot. And then by the time you got about a half a mile away, you were at stage 1 where there are no earthworms at all. And I did not see any evidence of jumping worms anywhere there. But at this point, maybe you need to look in villages and cities, you know, because maybe they haven't even started to spread outside of those yet. Yeah. So that's all I have for an update.
So do you add your, I'm just curious how people update these invasive species maps. Do you add your geographic location finds to that map, or you put yours in research papers?
Mostly put them in papers, but come to think of it, I should probably enter the jumping worm from Western Massachusetts. I should probably enter that. I didn't. I forgot to do that, but because I know some exact locations there. I didn't check to see if they were already in the Northampton area and the area between there and upstate New York, whether those areas are already shown in iNaturalist or in EdMaps. I don't think so. So yeah, for some reason, people don't put jumping worms in EdMaps or iNaturalist in the east, except for Vermont, but so, and Maine now. Maine has a really good map now too.
Yeah, I think that's Gary Fish's group.
We know that they have full coverage from Virginia up to Maryland, because the group from Johns Hopkins has published papers about them. But it doesn't show anything on EdMaps from there.
Well, that's what we were talking with Laura earlier, that it seems like the scientists who publish research papers, you know, don't update the invasive species maps.
Yeah, but yeah, Kathy Slavich, who's at Johns Hopkins and also works in the Smithsonian Research Forest there, she's had jumping worms there for years, and she actually knows quite a bit about them. And she also has a long-term earthworm exclusion experiment where there are electrodes in the soil that just automatically fire every so often. But I haven't, maybe she's waiting for a longer period before publishing the data from that, because I haven't seen.
So she is trying those electrical. At the last blog, we talked about that, and we went on to Amazon. You can buy them. So she is trying those.
Yeah.
Yeah,
So
okay.
I'm just wondering if she's done it long enough that she's ready to write a paper yet. And yeah, and she's done some earthworm exclusion experiments where she dug up like a big monolith of soil, like 1 meter by 1 meter, and wrapped it with some sort of cloth or screen or something to keep worms out and then grew tree seedlings with and without worms in, in soil in the forest, not pots in the greenhouse.
Right.
Yeah, so she's done a lot of really innovative stuff. We should probably check her website and check her recent papers to see what she's doing.
I definitely would do that. Thank you very much. Anybody else we're missing? Any other researcher? That you can think of, Lee, we should look for their papers?
Let's see, yeah, there is a group at the University of Toronto. I don't know if they've mentioned jumping worms in any of their papers. I haven't looked recently. Some of the, yeah, I mean, there's one earthworm researcher out in Nova Scotia, and then there's some in the Toronto area. So it'd be interesting to see if they mention jumping worms on any of their research sites. And I don't know if they have, if EdMap continues into Canada or not, or if there's something like that in Canada.
Yeah, I don't know that
It
either.
goes through Canada. Yep.
Okay. Well, then we should check. I think with the options that most people have when they display the map, it just doesn't show Canada, but maybe there's data there, but you have to tell it you want to see it or something.
Well, thanks, Lee. We'll look up Slavich's work and try to get it on our list and maybe get some excerpts from some of her papers. So thanks a lot for all those.
Sure, yeah.
Did I miss anybody? I think everybody's spoken but my lab. Is that true?
Can I ask a question real quick?
Sure.
I was just like, Lee, when you mentioned that forest where the jumping worm invasion hasn't moved, like, are those only European worms or is it European
Oh,
and
yeah, that one is European worms. And it's in the Porcupine Mountains. So obviously the biotic conditions in the soil, if European worms can't live there, jumping worms probably can't live there either, so.
would be a really cool study. I am not a scientist, so I'm just talking, but like if there's something in there, it would be really
Yeah.
cool to dissect that, test it against jumping worms and see if there's some
Yep. And the other thing, I have never seen a jumping worm location that didn't have European earthworms first. And I've looked in all these earthworm-free areas and I have never been able to find that. And I don't know if the only reason is that it's only remote areas that still remain without European earthworms, and they're also too remote for jumping worms to get there, or if the jumping worms require the European earthworms to have been there first. I just don't know.
Lee, can they coexist, European earthworms and jumping worms?
Well, according to Tyler Bauman's data from the Arboretum, the endogeic earthworms can coexist with Amynthus, but the nightcrawler cannot. Probably because they both feed right at the surface. And so they're competing directly for food, whereas the endogeic worms, are just eating dissolved organic carbon and fungal hyphae and stuff like that deeper in the soil. And they stay deeper in the soil than the Amynthus ever goes. So I guess I'm not too surprised that some of the sites have endogeic earthworm persistence and coexistence with Amynthus.
Tyler also wondered if the jumping worm castings and their activity might hinder the entrances and exits to the lumbricus burrows.
Yeah,
kind of
that
like nailing your neighbor's door shut so they can't get out.
Yeah, I mean, it would be very disruptive.
Yeah. I will say that in the forest trials, Lee, I sent you that picture of what I think was Lumbricus rubellus. So as the jumping worm populations crashed due to the drought, Lumbricus rubellus seemed to recover.
Yeah, Yeah, the European earthworms are much more drought tolerant, and they're also much more tolerant of low oxygen conditions. So they can go deeper in the soil if there's a drought or the oxygen levels are really low. And then when it rains again, they can come back to the surface. Whereas Amynthus is apparently intolerant of low oxygen. It has to be near the surface. It does not have the ability to drill through soils with very high bulk densities. That would be deeper down. Whereas for European worms, we know that they can move through the soil and pry it apart and move between the soil particles. But if you get deep enough, they just open their mouth and become a tube. And they can just drill through soil with incredibly high bulk density, like 2 or 3 feet below. And I've seen no evidence that Amynthus can do anything like that. So yeah, Amynthus has really limited tolerances for levels of oxygen, levels of water, and soil bulk density.
Frustrating that since such a sensitive creature is still causing so much damage and we can't seem to stop it. I have one last weird question, but in that I'm fascinated by this forest. Do you know if there's a lot of like salamanders and amphibians who happen to live like past that line? Like I'm curious if there's something that's bothering that ecosystem.
Yeah, those old growth forests with the intact forest floor do have a lot of salamanders.
Interesting, and no earthworms moving past that. That's cool.
Yeah.
So European earthworms are so much bigger than Amanthus. Why do you think that Amanthus wins out on surface competition?
Well, the European earthworm species actually vary a lot in size. A lot of the endojeics are not all that big. Night crawlers are a little bigger than Amynthus agrestis and Amynthus tokyoensis. I'm not sure that they're bigger than Hilgendorfii, Metaphyre Hilgendorfii, which is the biggest of the Asian worms. And it used to be in the Amynthus genus, but now they moved it to Metaphyre.
And where do you find the distribution in the US of Metaphyre?
Well, according to Brad Herrick, those three species that I just listed live together. And we did see a few that we thought might be Hilgendorfii at the Arboretum, but we never were able to follow up with those with Sam James or one of these taxonomic experts to make sure. So
We can collect samples this summer, Vera, if you do
Yeah, I
want
think
us to
that's a
look into
really
that.
good idea.
yeah,
Yeah.
I mean, we were going to do that, and then we had the drought of 22 and then the drought of 23, and the whole so our efforts to look into those variations at the Arboretum were kind of derailed by the droughts.
We do think that the woodland azalea area at the Arboretum was where we saw the largest of the jumping worms. So that was where we thought that they were Metaphyre. But I also collected castings from there, and with Miriam's guidance, I extracted cocoons, but based on the size of the cocoons, just purely based on the diameter of the cocoons, she thought that they would be Tokyoensis
Oh,
because they were pretty small. She's like, yeah, typically Metaphyre cocoons are a little bit larger.
yeah.
I do want to point out that Laura and I have put some links in. Julie, I'm sure you've seen them, but yeah, Laura showed the ed maps for Canada. I put in the current label for the homeowner grade 7 concentrate. And then also, yeah, just the only website that I could find that mentioned the native range of Gracilis, which would be southern China, Southeast Asia, and it says mainly in the tropical regions.
Perfect. Thanks for pointing that out. I hope, Julie, you got a chance to copy those. I'm copying them now. So Lee, before we end for the day, these coins that people use, maybe I'm using the wrong term, that measure temperature.
Eye buttons.
How accurate are they?
Well, for temperature, they're fairly accurate. I've never been convinced that they do a good job with water. The ones, but you should ask Hyang-Soo about that because he's the expert. But I actually like the hobos a little better, but they're bigger, more expensive. I think they're a little more accurate, but they cost a lot more than iButtons. So, and we did use iButtons for Tyler Bauman's temperature measurements at the Arboretum. So yeah, I think they're acceptable for temperature. But you should calibrate each one before you use it in the field. Like make sure it's measuring the same temperature as the others, like if you have them all in a refrigerator or something. And then bring them up to lab temperature and make sure they're all measuring the same temperature before you deploy them.
Lee, help me out. They're like $110 each, right? The I button?
That must be the ones that do water and temperature. I mean, the iButtons should be much cheaper than that.
How much do you think they are? I looked them up and that's what I got.
I thought they would be more like $20 or $30.
Okay, I'll go back and look again. Do you have a vendor?
We'd have
Vera,
to ask Hyang-Soo.
I put the link for iButtons in the chat, Vera, and it does depend on what type of iButton you're getting. Some of them are as cheap as $5.65,
Oh,
and some of
okay.
them
All
are
right,
well
good.
over $100. Lee,
right.
what was the other one you mentioned? Not iButtons, but you said,
So the hobo,
oh, okay. How do you spell it?
HOBO.
Okay.
It's some sort of an acronym. And I've used hobos to do climate studies. You can put them under an upside down white kitchen funnel and tie it to a tree branch. We had like 100 of them throughout the boundary waters for 2 years in order to characterize the climate of different forests. And one thing we discovered is they don't go any colder than 40 below zero. And we had some days where it was like 56 below zero at the nearest weather station. So you don't get the extreme cold. For summer temperatures in the northern tier of states, they shouldn't have any problems at all. And they do have some hobos that are made for burying in the soil and that claim to measure soil water, but I don't know. I've never trusted the soil water measurements of any of those as compared to a TDR. So, a time domain reflectrometer, which I think gives a way more accurate soil water measurement.
Lee, what would you suggest for us for in the lab doing bioassays? What kind of meter to get?
For water?
Yeah.
Oh boy. How big are your pots?
So we're using 8x11 plastic bins right now.
Yeah, I wonder if you could get a small TDR and just the thing about TDRs is you have to stick it in the soil and get a measurement. It's not permanently in the soil continuously giving you measurements, but
That's
you can
okay. That's what we do. Once a week we get measurements. Yeah.
but there are ones that are made to use out in the field, and then there's others that are smaller that you might be able to use in a pot.
Okay, I'll look that up. Do you have a
But I've
manufacturer
never done it in pots, but I know there are small ones available.
Do you have a manufacturer that you know that's good?
No, I'd have to look it up.
I'll send you an email. Thanks. So Erin, do me a favor. Go to that website. The cheapest button I find is 45. The ones that are $1.02 are for some other function. So help me out, Erin. Check it out for me. Thanks, Lee. You're always just a vessel of information. And we appreciate it very much, learning from you. So few updates from my lab. Garima Gupta's here. She's our new postdoc and she's working on the Jumping Worm project. And she's been working on these bioassays, just trying to figure out what soil we need to do the best bioassays, and that's what they've been working on. And Julie started it last year, then Grima and Julie have been doing a second rep. And what they're finding, the cliff notes, is that if you add the core to the soil, if you add grit to the soil, mushroom compost, cow manure, and wood pellet compost, and then you put some form of chicken feed in it. There's one from eBay we've used, and there's another one we got from the worm farm. Either of those two substrates, you get the best worm survival, and they weigh the best. So at least now we know a good way to, keep our controls nice and healthy. So when we do these bioassays, our data is realistic. So we're kind of coming to an end with that now. And our jumping worm study failed. As I told you, Julie went out of her way to collect many times, and they kept dying in collection vessels. And then we had this hypothesis, the group, that maybe if they were warm, the adults would survive longer. But nope. In October, the adults all died, and they left cocoons. The cocoons started hatching, and that's why we went off to the taxonomy lab to make sure that we were identifying them as the proper species, and they were. And we have not been feeding them enough, so we have to get new ones and learn how to feed them better. So, Lee, we're trying to find something to feed them that are we can buy, because we have a lab, we do qPCR, and so I can't have a lot of bags of leaves in there. And so we've been trying bean sprouts and alfalfa sprouts and romaine lettuce as substrates for jumping worms. Which one, Lee, do you think would be the best? We don't know yet. We have to go out and get some more jumping worms to figure this out.
Boy, that's kind of hard to tell. I mean, those are all pretty soft, which is the main thing, that they're physically able to break them apart. My guess would be the lettuce, because romaine lettuce has a lot of nutrients in it and it's pretty soft, so it should be easy for them to eat it.
So do they have to eat it when it's soft? As it in the lab, it dries out pretty quickly.
Yeah, it
Can
has to. Oh, yeah, it has to be wet when they eat it. They won't. No earthworms will eat anything that's dry, because if you think of an earthworm eating like a maple leaf that's dry, that would be like a human eating 20 or 30 pounds of flour,
Okay.
straight out of the canister. I mean, it's
Well, that's why we need this moisture meter, because we don't going to. So we're trying to do 30% humidity. Is that enough? 30% soil humidity.
That's a Kiangsu question.
Okay.
But yeah, whatever they eat has to be wet, because they don't have enough water in their body to process dry food.
So can you spritz the romaine lettuce with just just a little spritzer gun to keep it moist? Or would
Sure.
that be too much moisture? So that would work?
Yeah, that would work. I mean, they're most active at eating things in the field during rain and right after rain, when all the organic matter is soaking wet.
Okay, so when you said maple leaves, we kind of thought they were dry, but now they're not dry, they're wet maple leaves. Okay, that's
Yep. And you have to remember that dead leaves, they soak up water and they actually stay wet for quite a while. And dead leaves are mostly what they're eating. Although you might be surprised, they can pull cotyledons off of germinating seedlings and eat them
That's
too.
amazing.
So they can stand up, and like pull cotyledons off like an inch above the surface of the soil.
That is amazing. Okay. So if you wanted to get your CNN ratios tested, could you use just the soil testing lab on campus?
Sure.
Okay.
I will say that Jenna, for her bins in Brandon's lab, she did add some germinating plants in there too, because she thought that the jumping worms also appreciate having fine roots to feed on, in addition to decaying organic matter. And then she added some sand, because Lee had, I think, at one point said that extra texture helps them digest.
So we interpreted Lee's and sand as add grit, oyster
Yeah.
grit.
Yeah.
Lee, is it sand and oyster grit or just one or the other? Just help us out here.
Oyster, I don't know.
Oyster, you
I
don't
don't
know.
even know what oyster grit is.
It's ground up oyster shells.
Oh, sounds like the edges might be pretty sharp.
Okay, so you'd go with just plain sand.
And it has to be beach sand because you can't have any sharp edges. I mean, earthworms really love beach sand and, like from the sand dunes around the Great Lakes, because the sand grains are all rounded when you look at them under a microscope. Whereas if you dig up coarse sand that was deposited by the glacier and has been underground for thousands of years and you look at it under the microscope, it's like little razor blades.
And what do they use the sand for?
Well, it just helps grind up stuff inside the worm. And of course, the sharp ones and the big grains, they don't even allow it to go in their body at all.
Okay.
And you have to remember that the diameter boundary between silt and fine sand is an arbitrary human artifact.
So how many microns do you think?
Well, I think what's defined as fine sand, which is just slightly bigger than silt. If you look up the definition of silt and sand. And of course, silt is fine too, but earthworms like silt, but
So you have to go there, dig up the sand next to a riverbank. You can't buy it at Menards.
well, I don't know if their sand is going to be round grains or not.
Okay. All right. Erin, did you get a chance to look at those buttons? Did you see any below 40 bucks? Okay, I'll have to
No,
send-
but I put it in the chat, and the cheapest temperature ones are $44.25, and I wrote
Okay,
that
that's
I
what I
think
thought.
the cheap ones that I found were probably more location based buttons, not
Yes,
thermal.
exactly,
Yeah.
exactly.
Okay. Yeah, I did throw another link in the chat though, saying that, yeah, just talking about the digestive system in earthworms and how they do need grit in order to break down. They can still break down without grit, like sand, but it's much more efficient if they have that to help them out.
Are they actually harmed if they eat something sand-sized but jaggedy?
Yes.
I don't think, yeah, but I don't think that they actually pass it through their system. I think they have like a little gullet where it pools up and they kind of what we would think chew in that area, and then they only process the organic matter, and the sand or the grit remains in that gullet.
Yeah.
It's like a turkey eating stones
But
or
it
something.
will, if
Yeah.
you have coarse sand with sharp edges, though, it will cut the outside of their skin as they're moving through the soil, and they just won't live on that site.
How are they living in these forests where we're all post-glacial till and they're like having these devastating effects? Like they seem so delicate.
Yeah, well,
They don't
some of
go
that,
down. Yeah.
a lot of that till actually, was worked by the water for a long time while the glaciers were melting, and yeah, so
So thanks, Erin. I read this article and it says grit, sand, as Lee was saying, soil that contains very fine stones, and pulverized eggshells.
Yeah, I would agree with Lee though. Anything that could be sharp to their body, because we put a jumping worm on our table years ago at the Arboretum, tapped it to get it to thrash, and then I quickly dusted it with food grade diatomaceous earth, which is soft for us, but feels like shards of glass on them. The jumping worm immediately stopped moving and stayed perfectly still.
Interesting. Okay.
It was very interesting. Anybody could replicate it. Just tap the worm, get it to thrash around, dust it, it'll immediately stop moving.
There's something specific about the worm digestive system. Like what if you coated something like that with something, you made them all smooth and you coated it with something that the worm digestive system would break down and then they ingested something sharp.
It's getting it to stay on their food because one of Lee's forest trials from Mitpick was diatomaceous earth, and we didn't see any reduction in jumping worm numbers just from topically applying diatomaceous earth, and there's no real good way to work it into the soil anyway. And it is because it's injurious to their skin, we would also still kind of worry about what else in the soil are we harming with diatomaceous earth.
Got it. Yeah.
All right, so we got pretty big fat worms when we fed them on this Memes worm food, or we fed them on this chicken grit that was different grains ground up with oyster shells. So I'm going to put a call into this lady. Oh, she's called Memes Worms, if ever anyone, and she knows a lot. She sells the worm food, and I'm going to ask if she puts sand in her worm food. So we'll tell you that next fall.
Yeah, well, it doesn't have to be in the food. It can just be in the soil in the,
Oh, no, she sells the food. So I'm
oh,
just wondering if the food contains
okay.
the sand. So it's for people who compost with the red wigglers. Yeah.
Yep,
So we will try to figure out a way this summer to keep jumping worms around longer. And we
Yep.
definitely agree with everybody else that it looks like they need some kind of organic material like leaves or romaine lettuce or bean sprouts to feed on.
yep. And of course, leaves, have phytoliths, so, and those are little silica particles that are in leaves. And the ones, sedges have really sharp phytoliths, and that's why deer don't like to eat them. And I don't think earthworms like to eat mature sedge leaves either. But most leaves have phytoliths in them that are a lot smoother. The sedges have developed phytoliths specifically to prevent things from eating them. So they're like little razor blades. I mean, if you ever are walking around in a wetland and you swipe your hand the wrong way on a sedge,
Oh, yeah, they're very sharp.
it'll cut you right open.
That's right. Yeah.
But other phytoliths are totally smooth and round, and like the ones in maple leaves, I think, are pretty smooth. And that's like grit, and it's embedded in just about any type of leaf.
So maybe that's enough. If the romaine lettuce or the maple leaves have phytoliths, maybe that's enough grit.
Maybe, yeah. I don't know how many phytoliths romaine lettuce has, but
It's very difficult, doesn't it? Well, does anybody have any else to add? I know my lab learns a tremendous amount because we're not earthworm people, and so we're people who work with pesticides. So we came to this group because we're pesticide people, but in order to do our studies, we need to take care of earthworms. So thank you very much for helping us out and helping everybody with information transfer, which is real important. So we're going to say goodbye to you till September. Send us emails and we'll send an announcement out in September after the field season.
all right. Bye, everybody.
Bye-bye.
Bye. Thank you.
Erin, are you still there? Did you leave? Okay, I'll catch up with Erin. Jim, is there a time we can talk?
I guess I can probably make my schedule fit yours if there's a time that works for you.
You want to talk now? Everybody else is gone.
I think it'll take a little longer than we have, so.
Okay. So, let's see, tomorrow afternoon, I'm free after 3:30.
That'd be fine.
Okay, I'll send you a link and talk to you at 3:30.
Okay, great. Thank you.
All right, bye-bye.
Bye-bye.